Moving on to question number 1. In figure 6.28, find the values of x and y and then show that AB is parallel to CD. Here, let us name the given unknown line as L. Now, moving on to the solution. Here, if we consider AB is line intersected by line L, we can say that angle 50 degrees and angle X form a linear pair. We know that sum of angles that form a linear pair is equal to 180 degrees. Angle 50 degrees plus X is equal to 180 degrees. That implies on transposing 50 to right hand side we get X is equal to 180 degrees minus 50 degrees, that is equal to 130 degrees. Again, if we consider the line CD is intersected by line L, angle 130 degrees and angle Y here are vertically opposite angles. We know that the vertically opposite angles are equal. We get Y is equal to 130 degrees. Therefore, here we found the unknown values, that is X is equal to 130 degrees and Y is equal to 130 degrees. Here, if we observe clearly, AB and CD are two lines intersected by line L, and here if we observe clearly, angle X and angle Y are alternate interior angles which are equal. Therefore, we can say that AB is parallel to CD with L as transversal. Now, moving on to second question. In figure 6.29, if AB is parallel to CD and CD is parallel to EF and Y is to Z is 3 is to 7, then find X. Now, moving on to the solution, he has given Y is to Z angle ratio as 3 is to 7. Let us assume that Y is equal to 3A and Z is equal to 7A. Now, in order to find the value of Y and Z, we consider the second case, that is CD is parallel to EF and it is intersected by a transversal that is unknown, and let us name it as line L, which intersects P, CD at Q and EF at R. Now, as CD is parallel to EF and L is transversal, we can say angle CQP and angle DQR are vertically opposite angles. Therefore, those angles will be equal. Therefore, we can write angle CQP is equal to angle DQR will be equal to Y, as they are vertically opposite angles. If we observe clearly, here CD is parallel to EF and L is the transversal. Here angle Y and angle Z are interior angles on the same side of transversal. We know that sum of interior angles on same side of transversal is equal to 180 degrees. We can write Y plus Z is equal to 180 degrees. That implies Y we assumed as 3A and Z we assumed as 7A. That will be equal to 180 degrees. That implies 10 times A is equal to 180 degrees. Now on transposing 10 to right hand side, we get A is equal to 180 degrees by 10, that is equal to 18 degrees. Therefore, angle Y is equal to 3 times A, that is 3 times 18 degrees, which is equal to 54 degrees. Again, Z is equal to 7 times A, that is 7 times 18 degrees, is equal to 126 degrees. Here he asks us to find the value of x. So let us consider the first case, that is AB is parallel to CD and L is transversal. Here again, if we observe, x and y lie on the same side of the transversal. We know that sum of angles lying interiorly on the same side of transversal is equal to 180 degrees. We can write x plus y is equal to 180 degrees. That implies x, the value is to be found, plus y, we got it as 54 degrees, is equal to 180 degrees. That implies we get x is equal to 180 degrees minus 54 degrees, that is 126 degrees. Therefore, finally we can say that the value of x which we required is 126 degrees. Now moving on to the third question. In figure 6.30, if AB is parallel to CD and EF is perpendicular to CD and angle GED is equal to 126 degrees, find angle AGE, angle GEF and angle FGE. Now moving on to the solution, he has given that angle GED is equal to 126 degrees, that is angle GED 126 degrees. Now if we observe clearly, angle GED is consisting of angle GEF and angle FED, that is angle GEF plus angle FED, that is equal to 126 degrees. That implies angle GEF plus angle FED will be 90 degrees, as FE is perpendicular to CD, that is equal to 126 degrees. That implies angle GEF is equal to 126 degrees minus 90 degrees, that is equal to 36 degrees. Therefore we got one of the values which is asked, that is angle GEF is equal to 36 degrees. Again, if we consider the triangle GEF, here we know that sum of angles in a triangle is equal to 180 degrees. We can write angle GEF plus angle EFG plus angle FGE is equal to 180 degrees. That implies angle GEF is 36 degrees, we got in the above, plus angle EFG will be 90 degrees, as FE is perpendicular to CD and AB is parallel to CD. Therefore EF is also perpendicular to AB, that is angle EFG will be 90 degrees plus angle FGE is equal to 180 degrees, which implies 126 degrees plus angle FGE is equal to 180 degrees. That implies angle FGE is equal to 180 degrees minus 126 degrees, that is equal to 54 degrees. Therefore we have got the other unknown value, that is angle FGE is equal to 54 degrees. Here we got the two values, that is angle GEF and angle FGE. Again we have to find the angle AGE. He has given that AB is parallel to CD, and if we consider the AE as transversal, then we can say that angle AGE and angle GED are alternate interior angles. We know that when lines are parallel, their alternate interior angles will be equal. Therefore angle AGE is equal to angle GED which will be equal to 126 degrees. Therefore, we can write angle AGE is equal to 126 degrees. Here, thus we got the three unknown values that are asked, that is angle AGE is equal to 126 degrees and angle GEF is equal to 36 degrees and angle FGE equal to 54 degrees. That's the solution. Now, moving on to the fourth question. Here, in figure 6.31, if PQ is parallel to HT, angle PQR is equal to 110 degrees and angle RST is equal to 130 degrees. Find angle QRS. And hint given is that draw a line parallel to ST through point R. Now, moving on to solution. Let us note down the given information, that is angle PQR is equal to 110 degrees and angle RST is equal to 130 degrees, and also given that PQ is parallel to ST. According to hint, let us draw the line parallel to ST passing through point R, that is line AB is drawn parallel to HT and passing through line R, and as HT is parallel to AB, we can say that PQ is also parallel to AB. In the case 1, let us consider that PQ so parallel to AB and QR as transversal. Then angle PQR and angle ARQ are the angles that lie on the same side of transversal. We know that sum of angles lying same side interiorly on the transversal is equal to 180 degrees. Angle PQR plus angle QRA will be equal to 180 degrees. That implies angle PQR is given as 110 degrees plus angle QRA is equal to 180 degrees. That implies angle QRA is equal to 180 degrees minus 110 degrees, which is equal to 70 degrees. That is angle QRA is equal to 70 degrees. Again, if we consider in the second case that ST is parallel to AB and SR is transversal, angle TSR and angle SRB lie interiorly on the same side of transversal. Therefore, the sum of angles that lie interiorly on same side of transversal is equal to 180 degrees. Angle SRB plus angle RST is equal to 180 degrees. That implies angle SRB plus angle RST is given as 130 degrees, which is equal to 180 degrees. That implies angle SRB is equal to 180 degrees minus 130 degrees, which is equal to 50 degrees. Therefore, we got angle SRB as 50 degrees. If we observe the figure clearly, we can say that angle QRA, angle SRB and angle QRS lie on the same straight line. Therefore, the sum of angles lying on the same straight line is equal to 180 degrees. We can write angle QRA plus angle SRB plus angle QRS is equal to 180 degrees, which implies In the first case, we got angle QRA has 70 degrees plus angle SRB is 50 degrees plus angle QRS is to be found, that is equal to 180 degrees. That implies 70 plus 50 is 120 degrees plus angle QRS is equal to 180 degrees, which implies angle QRS is equal to 180 degrees minus 120 degrees, which is equal to 60 degrees. Therefore, the angle required QRS is equal to 60 degrees. Now, moving on to the fifth question. In figure 6.32, if AB is parallel to CD, angle APQ is equal to 50 degrees and angle PRD is equal to 127 degrees, find X and Y. Now, moving on to the solution. He has given that AB is parallel to CD and angle APQ is equal to 50 degrees and angle PRD is equal to 127 degrees. He asked us to find the value of angle X and angle Y. In order to find angle X, let us assume that AB is parallel to CD, which is given, and let us consider PQ as transversal. Here, if we observe that if AB is parallel to CD and PQ is transversal, angle 50 degrees and angle X degrees are alternate interior angles. Therefore, we can write X is equal to 50 degrees as alternate interior angles are equal when lines are parallel. The second case, if we consider triangle PQR with the interior angles X and Y opposite to the exterior angle 127 degrees, we know that exterior angle is equal to sum of two opposite interior angles. We can write angle 127 degrees is equal to the sum of two opposite angles, that is X and Y. That implies 127 degrees is equal to X, we got it as 50 degrees plus Y. That implies in order to find the value of Y, we need to transpose 50 to left hand side. That is, Y is equal to 127 degrees minus 50 degrees, which is equal to 77 degrees. Therefore, the two unknowns which he asked are X is equal to 50 degrees and Y is equal to 77 degrees.